it'll be like how we did yesterday?
It is just like what we did yesterday.
Like 1/4?
This would be the total number of times that the event actually took place.
Uh-huh.
So if I rolled a number cube and I was recording the number of times 1 showed up, it would be every single time that I got a 1. And the bottom number would be the number of times that I actually rolled the number cube.
You'll divide those?
And you'd leave it as that simplified fraction. Okay? So, same concept as what we did yesterday. So, let's take a look at this your turn, number 7. A spinner has 3 unequal sections, red, yellow, and blue. And the table shows the results of Nolan spins. Find the experimental probability of landing on each color. So, they're looking for the probability of red. They're looking for the probability of yellow. And they're looking for the probability of blue. In order to figure the probability, I've got to figure out how many times did he do this experiment? How many times did he spin the spinner? How would I find it? I'd add all these together. 10 plus 14 is 24, plus 6 is 30. 30 is my total. Everybody with me so far with experimental probability? Probability of red. How many times did red show up? 10. 10 over 30 will simplify, and I should simplify it. What does it become? 1 over 3. Yellow. 14 over 30. It too will simplify. 14 and 30 are both divisible by 2. It goes into 14 7 times. 2 goes into 30 15 times. Probability of blue, 6 out of 30. 1 out of 5. Experimental probability will always have data. Always. They had to do an experiment to get experimental probability. It'll always have it. Question so far? Am I good? Can I go to the next page? A toy machine has equal numbers of red, white, and blue foam balls, which it releases at random. Ross wonders which colored ball will be released next. Describe how a standard number cube could be used to predict the answer.
Well, like if you roll the cube, um, it's kind of like how if, um, like say that you got a 3, if you and you got 6 sides, the 6 sides, there you kind of I don't really know. You could think of the 6 sides
has red, white, and blue, but there'll be there'll be two red, two white, two blue.
Very good. So what you'd have to do is you'd have to let a pair of numbers, maybe 1 and 2, represent what color? Red. And then you'd represent 3 and 4 maybe would be what? White. And then you'd let 5 and 6 represent blue. Okay? Now there are 3 equal chances. And what could he do now? Roll the dice and record the theta. Roll and record. By the way, how many times should he roll the dice?
2, 1.
Okay. The more he rolls it, the more data he has, the more close it will approximate the theoretical possibility. If I only roll it once, it's probably not a very good. If I only roll it 3 times even, it's probably not a very good idea. Because I'm only going to have 3 possible outcomes. I'd want to think that I'd want something to show up multiple times so that I can see how close it would be. Theoretically, they should all come up about equal. But if you rolled a number cube ever before, and I'm sure you have, you played some kind of board game where you rolled a die, then you're going to find out that every once in a while, a number shows up time and time and time again. Like you just can't seem to get off of a particular number, or you can't get the number that you really need. On some of the games, you need a 1 to get out, right? And if you don't roll a 1, where are you stuck? You're right where you're at. You can't go anywhere.
I've never rolled a 1 in my life.
Okay. So, does everybody understand that I had to group this? And I had to group it so that there was 3 equal chances. Would this had to have been 1 and 2?
No, it could be.
It could have been, this could have been 1 and 4 or 1 and 6. Wouldn't have made any difference so long as there was 2 numbers in each one of the colors that I assigned. That makes sense to everybody? Are we good? Let's find out how good we are.